I crack open my Arizona green tea here. There's been an interesting asteroid that's come up recently that's gotten a lot of the news on YouTube and other places. But I noticed nobody's doing any kind of investigative research on it, so I kind of started doing that. It's called the Cigar asteroid, and if I can get my graphic art skills, which are growing. Some of the stuff I was doing is pretty amateurish. I mean, skills in graphic arts are growing because I have been taking some courses in the evening. Even though I look at my age, you're like, well, I should know everything. I don't. You know, technology is like changing every 6 months. So, you know, but it's a new skill, and it's kind of fun because it is art. So I've made challenged myself to, you know, keep improving my graphic art skills and my knowledge in astronomy and stuff and science throughout the year. But the cigar asteroid is one that's come up recently, and you know it's just like a cigar, and it's different from all the other asteroids because most asteroids are round, and this one's obviously cigar shaped. So, you know, that green brings up a good question mark as to what its origins are, you know, and if it came from a planet, you know, there's a guide here. It's called the Sedimentary Rocks and Field Guide by Dorrik A.B. Stow. Here's what it looks like, and this is one of those pocket guides that you can actually go out into the field with and carry with you to do any kind of geological research. And so I was kind of looking through here, and the best places I could find anything that looked like that if it came from a planet, it's in volcano beds or rocks that kind of look like that. You know, I wish I had a projector where I could projected these really to do it right, but you know, I had to go with what I've got. But there's a lot of good information there if you're looking to find out what possibly might be the origin of that asteroid. You know, I pick up this book. It's a library book, unless you want to pay $105 for it. You know, it's one of those research guides for serious geologists. So, you know, they're not bestsellers, so they're going to move the price up on it. So it's about $105. So if you can't find it at the library, you're going to have to cough up $100 at least, you know, for it. But it's got a lot of good information and data and stuff and pictures, so you can wade through this pretty quickly to see what that asteroid might have possibly come from. But you got like volcanic fields, you got riverbeds are pretty common. You got like most of these are limestone, sandstone, creates those kind of rock organizations, and it shows you over here as to you know, what's the history of those rock layers are. But you know, you get a lot of, when you get rocks under pressure and fractures and stuff, it fractures the fractures like this. But the problem is that asteroid is in outer space. So, you know, brings up the dilemma as to how it got out there, if it came from a planetoid, you know. So but there's a lot of possibilities, and that's one of the things you can discover in this book, this guide here. So I came up with some pretty good, pretty quick data research as to where that possibly might have come from on a planet, but it's iron. So But anyways, the other book I've been reading is the Cambridge Planetary Sciences one on asteroids. It's been out by Thomas Burbine. It's a Cambridge Planetary, Cambridge Library series book, and it's got a lot of this specifically on asteroids. This is put out by University of Cambridge in UK and New York and Melbourne. They do a lot of good. They put out a lot of good books, and it's got an extensive reference guide. And you go back to the back page of the reference guide. A lot of this stuff is just taken out of journals, science journals and stuff. So besides just, you know, getting some good data on asteroids, recent data, because this one came out in 2017, so it's about as recent as you can get, so it's up to date. It doesn't cover that asteroid. That asteroid has come up pretty recently, so it won't be any mention on the cigar asteroid. But it's got good data on some of the other asteroids out there. But there's a lot of reference guides here. And, you know, as far as information, a lot of this stuff came from magazines and stuff in science journals that'll never make it in the book. And so, but if you're going to do a lot of extensive study on asteroids, you got a good reference guide where that's coming from. So, as long as the freedom of information stands out there, and you got access to data, you know, you can still do some. You know, research on that kind of, a little bit more extensive for the people that don't just want to know a little bit more about that cigar asteroid than most people do, you know. But, you know, there's a lot of journal stuff that research that went just into science journals and will never make it into book format. So, you know, take a couple months just to cover all these reference guides, and hopefully they have pictures and stuff, and try to figure out what that asteroid, where it came from, and what it possibly might have come from. And whether some asteroids did come from planets, but others have other origins. Some are just planetary asteroids that never were planets, but comets do have helium and hydrogen, and, you know, do indicate that they came from an Earth-like world source. You know, how they get out there. You know, did they fight some big space war in the Milky Way galaxy? Well, don't know. But I mean, studying asteroids give you a little bit of a history out there as to possibly might have been part of the Milky Way galaxy's history. So that's why it's important to study asteroids, because it's our only archaeological evidence out there as to what possibly is the history of the Milky Way galaxy. So it's very important research. And I'm only going to cover books that, you know, I think there's pretty, especially I'm going to emphasize, that's going to give you some of that history as far as the galaxy goes, and where you would go to get that information. And asteroids is one of those specialty areas of research that's pretty important, because it's the only archaeological stuff that we have that give us any kind of history of the Milky Way galaxy is that what possibly have gone on out there. You know, so, you know, it's pretty important. Even though they're just rocks floating around out there outside the planet Earth, it's the only thing we have in archaeology that you can actually give us some indicators of where that stuff came from, and, you know, give us some history. It's, you know, it's only archaeological data. You know, time goes back millions of years. Maybe they might be billions of years. Their system of dating asteroids and stuff may or may not be very accurate. So you can't, you know, but it still beats not having anything at all as far as dating goes. You know, know, give you some idea of how old the asteroid is and, you know, where it possibly might have come from. So, you know, it's a pretty good book for that. I think the price tag on this book is about $100 too, so it's a library book, but I'm hoping you get a copy of it eventually. I think they sell it at Amazon for I think it's $100 too, so if you don't got $100 in Nula, you might be able to find this book down at the library. But anyways, kind of gives you the history and of all the new spectrometrical data that they're getting off asteroids and stuff. And I made notation. Here's the electromagnetic spectrum. It shows you the different wavelengths that you get for humans, honeybees, protozoa, molecules, atoms, and stuff like that. So when you're getting spectrometric data off a asteroid, obviously you're not going to find humans on that, and you're not going to find protozoa, molecules, maybe atoms, but you know, you're limited in what kind of data. It's just lifeless rock. You know, unless if it came from an Earth-like world, you would have to be able to bring in pieces of it and stuff and put it under a microscope and see if you could see any fossil evidence. But we haven't been out to an asteroid other than just just by remotes out there. So you know, it's not something. It's not like we've been to the moon where you got to collect rock samples and stuff. But it also gives you the temperature readings and stuff like that. So the spectrometry is improving. So you get a lot of good information from spectrometers. All talks about, gives a good example of black body radiation. I always apply that as to human beings, but they also get black body radiation readings from asteroids. And it's from the long-term effects of being exposed to the sun. And they also get, it's kind of like radiocarbonating. They get some dates and stuff, how they think the asteroid is, by what kind of spectrometer readings they're getting from the black body radiation and how much time it's spent out there in orbit around the sun. And it's kind of, you would say, well, if the solar system was uniform and all those asteroids came from, had just been a part of the solar system, all that data should be pretty consistent in aging and stuff. It all should be pretty, especially if it's outer space, it should all be equal about the same level, but it's not. That's not what they're discovering. They're discovering that asteroids have different compositions and stuff. They're also, what they're discovering out there is that they're able to classify the asteroid fields, the certain types of asteroids. So, which brings up the question is somebody, since they're able to classify those, and in the asteroid fields, they'll have an asteroid field here, an asteroid field over here, and an asteroid field over there with a different type of asteroid, and they call them satellites of the main body or something, but they've been sorted out. And something out there, if you want to know, well, what is ET doing out there, it indicated that something out there was actually separating the asteroids in the same classification. That something out there has moved those around and has sorted them out so they can use them for different purposes and stuff. So, you know, a lot of too many astronomers out there just don't want to accept the fact that there's something living out there that's high tech, that has visited the planet and stuff, and is actually working out there in outer space, you know. But there's a civilization out there that does have the science, so it's not a dead universe. It doesn't mean that they're, you know, that they sorted the asteroids out, they put them out there, and they got them where they want to, and they classified them, and they put them in maybe a Starship's databank or anything, and then they took off, and they've got pretty much, if they can move around, they've got the whole galaxy. So just because we're just still earthbound people doesn't mean there's not a civilization out there that does have the ability to do that, you know. And we're kind of like Native Americans, whatever, to them, you know. Are they going to interfere with our civilization, you know? What do we have to offer them since they have the ability to actually get out here to this planet, you know? So they kind of look at us like, you know, well, you're kind of an up-and-coming civilization, but we can go all over the galaxy. So we look like Native Americans to them. But anyways, that's what they discovered. It gives you temperature readings and stuff that they had of the different asteroids. There's a lot of information on black body radiation. Okay, some of the I'm trying to find out why I marked this. Some of the asteroids do rotate, and according to them, it's how the sun's rays hit the asteroid and its composition that actually kind of makes it tilt on its axis, which is what a physicist's explanation of that is. But I'm going to add another suggestion is that there might have possibly been ET out there that moved it, and so, you know, that's a PhD in physics explanation for it. But I would say, because what the problem with that is that not all the asteroids in that field are rotating, only just some of them. But the physicist is saying that it's the composition of the asteroid and its structures is what's causing it to move. So that would be the explanation. But none of the other asteroids are moving, only some of them are rotating. They're not all rotating. So to me, that kind of brings up pulls a flag with me as to possibly one might have made that move out there. But either way, you know, it's kind of a clue as far as what made those rotate out there. It's like a boat going across the lake. It leaves a weight and it moves anything that's in its path out there. So, you know, high-tech spaceships do that. And we know that's not just empty space out there. It's actually something that you can actually warp and stuff. And with high-tech engines and stuff, you can actually bend. And that's going to move an asteroid or make one move or create a gravitational wave or something. So it doesn't mean that that's not going to make that asteroid start spinning, you know. So especially if it goes by pretty close by. So, you know, it's possible that if you go that route, you think, well, you can classify all the moving asteroids out there, and you can possibly see where maybe possibly a spaceship has gone around out there. So you're getting kind of maybe some clues as to what possible areas of the solar system out there that spaceships have been through. You know, it's kind of far-fetched, but I mean, it's a possibility. Kind of gives you the history of spectrometer readings and CCD imaging. That goes back to the 1970s, I think. That was the first digital, 1980s, the first digital processing they had to be able to take pictures out there and stuff. So it kind of gives you a history of some of the technology. So, you know, kind of down memory lane. Tells you some of the space telescopes, Hubble telescope. They had the Wide Field Infrared Survey Explorer. I think it's called WISE. Yeah, WISE. Yeah. There's a good picture of WISE in here. Gives you the history of what those spaceships discovered. So that's pretty important, you know. You want to cover different data and stuff and see what they did, learn from it, and then, you know, kind of analyze it yourself. Because, you know, the guess I have a code of science when it comes to talking about suggesting that there might be extraterrestrials out there. So, you know, you have to kind of do the investigation yourself as to, you know, what the data says. So, you know, but there's a lot of, there are some, you have to put it together. There's also, here's orbits. I wish I had a good, I wish I had a viewer where I could show you these, but it shows you the orbits, it shows you the asteroid field, and it shows you that they're broken up into different segments, families of asteroids and stuff. So somebody out there has actually, you know, moved those around and put them into families of asteroids to that they want, and they're not all the same composition. I'm going to go into that further up here, I think, looking through here where I made notations. Oh, yeah, thermal radiation and the rotation of asteroids. You can read into that. You can make your own judgment call as to whether that was an extraterrestrial spaceship that made that asteroid rotate, or it's just the sun, you know. That's a physicist's opinion on that, so, you know. But, okay, yeah, here we go. This is good data here. It's chemical composition of the asteroids. Well, it's not consistent. Think they're all asteroids of iron? Guess what? They're not. So, we discovered that there are different compositions. You got, oh hell, there's like there's at least about 35 different mineral compositions of asteroids, minerals they've discovered with asteroids. Olevine's a lot of them. Metallic iron, different branches of olivine mineral. Plagioclase, graphite, pigeonite, olivine, orthophosphine, triloxane. I've got a mineral book, so, you know, to do a proper research on this, you have to also get a mineral book. I didn't have a whole lot of background in mineralogy. My knowledge of that's growing, you know, and how minerals are put together. So don't think I'm always correct, because my knowledge in minerals is growing. But I mean, it's you know, you have to have a broad background. So what does mineralogy have to do with astronomy? Well, when you get down to classifying asteroids and stuff, it has everything to do with it, because they're not all the same composition, you know. It gives you different. Some have oxygen isotopes in it, so that doesn't mean they didn't come from a planetoid like Earth. You know, they got oxygen isotopes in it. They've classified those between here and Mars. You know, the physicists suggesting some of that may have come from Jupiter, from blast back from Jupiter. You know, but it's hard to say. You know, it's even suggests that because that, you know, or it was that it isn't something that came outside the solar system, but I would suggest also the reason why some of those are oxygenated asteroids, because ET has the ability to move asteroids in asteroid fields. All asteroids have been tumbled. You're not going to find that in this book, but if you put your common sense together and you look at what you know out there, go to any kind of rock tumbler, and you can get the same effect that you see on asteroids. In fact, just maybe a day or 2 days of tumbling rock, you get pretty much what you see out there on asteroids. You do it for maybe an entire 2 weeks, and you get the nice smooth pearl-like rocks that you don't see in asteroids, except maybe like Ceres, which is a planetoid. it's not really considered an asteroid. It's more of a dwarf planet. It's actually round. You get that, and their explanations for why it's, they said the gravity is what pulled it in. Gravity doesn't have this. Only heat can actually mold something like that. So their explanations as to why Sirius is still around is inconsistent. No gravity, nothing gravity out there can actually create that round of an asteroid. It's just like a pearl. There's something out there that's actually molding that asteroid, superheating it, and actually crater. That asteroid was created by design. It was left out there for a reason by AT. And if they want to live in a dead universe, that's their business. But ET is out there. It doesn't mean ET just kind of, whatever reason they left the asteroids out there, and what they plan on using them for, we don't know, because we're not ET. We don't have the science, and we don't have the engineering and technology. But it gives you good examples of different types of asteroids out there. And you want to compare the stuff in this book, as far as the composition of those asteroids goes, with the lunar rocks, because some of the asteroids have the same composition as the moon. So the moon, I said earlier that the moon is actually created. All the planets are created out there. So some of that asteroid is left over. Well, they decided they didn't need to build the moon up anymore, and then so they just left it out there. So it's just like building a house or something. There's stuff that's left that they bury out there in the yard and stuff that they didn't use, and it's there, as geological history, So, it's the same. It operates on the same principle. But there's a living alien out there that's actually utilizing all that, and that's what you have. That's the only reason why I get into investigational science and data, is to figure out what is God out there, and what is ET doing out there. What do they have the ability to do, and what do they use to create the galaxies and stuff? Without those questions, there's no point even getting into science and engineering and what else. What have you got to live for if you don't believe in higher levels of science and higher levels of intelligence and stuff of extraterrestrials out there? What's the point of even getting into science and engineering and stuff? Because it gives you something it gives you kind of a goal, and it's kind of an inspiration for getting involved in science and stuff, to try to figure out how they create those planets, how they create galaxies and stuff, and just have the knowledge and information of how they do it. It's just like art. It takes time to learn art, but once you can learn the art, you can actually paint and do pretty good paintings and stuff, but it takes time. And with us, it's taken us 5,000 years to get to this point. So, it takes time, and it's more than what one person can do in one lifetime, but over the series of years and stuff, gradually we get to emerge to this point now, which, we're actually getting some answers out there, because we can actually get spacecraft out there and come up with data. And hopefully the Freedom of Information Act stays out there, so, you can kind of, put the clue together to figure out what is doing all that out there. And how the universe and stuff came into being. Let's see here. Okay, there's different families of asteroids that they actually classified, grouped, clumped together as the Vesta family, the Flora family, the Coronis family, the Eos family, and it shows you how many asteroids are part of that family. Like the Juno family, there's like 1,684 asteroids associated with that family that are part of that local network. And there's like, you can go down here and you can see how many different families of asteroids that all came to are the same source. So something that I suggest, if you see it, go on my intelligent designs playlist, you'll see the what they used. I think they used either put those asteroids together. It's kind of a cosmic glue dance. They did an experiment off the International Space Station where they actually put two electrodes together, kind of similar like this, and they're actually able to just fire off and create a kind of a plasma that hardens, which is consistent with those Hubble Space Telescope's pictures of nebulas and stuff, where they're actually star forming and they're building solar systems and stuff. You find these honeycombs, and it's in the Hubble pictures. I'll try to put the pictures up in on some of those, but you can see it's kind of a cosmic honeycomb. They're just huge, and they just put all these asteroids. Either possibly they put the asteroids together and they send them to wherever they're going to work, and create solar systems out there. They weld them all together, caught them together with this cosmic glue, and they heat it and break it up and stuff, and then use it for whatever they want to. You know, that's the only reason why those could possibly be out there. Other than that, another suggestion I might have is that it's a space station, and they've got a lot of people living out there, and it's kind of a floating space station. Instead of having structured kind of like what you have up at the International Space Station, they build whole cities and stuff within that molded, hardened honeycomb stuff. You know, just like a beehive, but you can actually survive, live out in outer space, and you know, which might be a possibility. But let's see. Yeah, that's not. I already talked about that. But it also talks about comets too. Gives you some pictures of comets, and the theories on the Oort cloud and what's the chemical composition of the comets, and obviously they came from an Earth-like world, so that's a big question mark as to how the Oort cloud got out there, and none of them have any explanation. So you know, it's hard to you know, you got all these dead asteroids out there with just iron composition, and then you got these an Oort cloud out there with ice and stuff, water ice, that has Earth-like gases and stuff in it. And all I can figure out is possibly there might have been a space war out there, and that was once a planet. Two, it was brought in on Mars, and when they brought Mars out here, they had all that ice and stuff. They were breaking pieces of it off and then sending the water ice or the liquid soup to Earth, and that's how they were able to create our ocean and our atmosphere. That's a possibility, and in the process of breaking that stuff off and floating it out to the Earth and crashing into the Earth, it created the Oort cloud out there. That'd be a possibility, a second possibility. So I don't, you know, they don't have any suggestions on that, on how that got out there. So that's just one of my suggestions, you know. And I think they're the only ones that probably have suggested that, but they don't. They try to do it through a evolutionary process. It just doesn't work, you know. There's something living out there that's actually doing all that. And there's no point in getting into geology and stuff and unless you're going to think in terms of terraforming a planet. You know, we know how to build a house, we know how to build a building, we know how to build an airplane, we know how to build a spaceship that can go to the moon. So naturally, at some point in time, science should be able to, and engineering should be able to terraform a planet and actually create a planet. If there's something living out there, it can actually do that. You know, it's just only a matter of a sequence of time. And the time it actually is going, you can actually be able to do that. I call that inspirational science. Well, so much for this book. I've spent too much time on this one to do